We're solving equations with variables on both sides. This is the big thing. We're going to have variables on both sides. So we're going to continue to use this acronym, don't call me a monster. Distribute, if you can, combine like terms on the same sides, move variables, add, subtract, multiply, divide. Okay, this is the new one. So when you look at number 1, we're trying to get k by itself in this case. When you look at that, there's one big glaring problem. We know how to get x by itself or variable by itself when there's only one of them. There are two. So what we are going to do is pick a side you want to get the variable on. Okay. Personally, I think it's going to be easier to get it to the left, and I almost always go to the left. Almost always. So I'm going to go ahead and kick this line up a notch. Okay, so I'm going to draw a vertical line on the equal sign every time when we get to this point, because we have to be very, very careful. So we want to get the k's on one side. I'm moving it over this way. So in order to get rid of it over here, I'm going to have to subtract 4k. Subtract 4k. If I do that from the other side, subtract 4k. I get combining like terms right here because it's over here now, but it's negative. So 7 minus 4 is 3k. Bringing this down, we just get 15. Now that's an equation I know I can solve. Okay, but that's really what I'm trying to do. I'm trying to get it where I only have one term of the variable in it. Now dividing by 3, we get k equals 5. Before I call that good, I'm going to pull up my calculator and check that, just like I've done every time. And just delete all that. So I'm going to have 7 times 5, because that is what I believe k is, equals, but I've actually got to put that 5 in two different places, equals 4 times 5 plus 15. And it is true. Checking is very valuable, especially when you have multiple variables. There's not a real, you can't just usually look at them and tell. So k does equal 5. Number 2, I'm going to go ahead and draw my vertical line here. I'm going to move the x over to the left. So I'm going to subtract 1x, that's actually what that is, 1x, and so we get 4x equals 8. Again, an equation I know how to solve. So I'm going to divide by 4, and x equals 2. Now, checking that, 5 times 2 equals 2 plus 8. And that is also true. So plugging it, make sure you plug it into both places. Everywhere there is an x or a variable, put it there. Okay, next, 3/4 x equals 1/2 x plus 5. This is going to be nearly identical to what we've done on the last two. The only difference is we have fractions. So we will subtract, if we want to move it over this way, we're going to have to subtract, it's positive, so subtract 1/2 x. So that's going to be 3/4 minus 1/2. So 3/4 minus 2/4, which is 1/4. 1/4 x equals 5. Now you can either divide by 1/4 or, my personal preference, multiply by 4 over 1. Divide by 1/4 or multiply by the reciprocal, in which case you get x equals 20. Okay, checking this. All right, we get 3/4 x, well, x is 20, equals 1/2 x, which x is 20, equals plus 5, and that is a true statement. All right. On to number 4. All right, looks like we're going to have another step here. First, I want to make sure, so I'm going to distribute, combine like terms. I can't distribute. Combine like terms, there's ends on both sides, but I can only put them together if they're on the same side. If they're on opposite sides, you can't do that. Okay, that's where the move variables comes in. So, move variables, don't call me a monster. Can't do that. Can't do that. Move variables, though. So we're going to first move the n. I'm going to go ahead and move it over that way. I like getting to the left, like I said. So I'm going to have to subtract 1n from both sides. Make sure you combine it with just the n term. So we get 2n, bring that down, minus 15 equals 3. Okay, now we're going to have to add or subtract because, well, we can do that now. So add 15, which should give us 18 equals 2n, and dividing by 2, n equals 9. All right, so if I plug 9 back in up here, that'd be 27 minus 15, which is, hold on, 5, I said 27, 12, okay, 12, and then I plug 9 up here, I get 12. So it's the same on both sides. 12 equals 12, which is true. That's good. All right, number 5, do the same thing. First, draw my line, subtract 5x, because I'm going to go and get it to the left. Subtract 5x. So in this case, I get negative 3x equals 0 pair, negative 3. Dividing by negative 3, x equals positive 1. Let me check that one real quick. If I plug 1 in, that's 2 times 1 equals 5 times 1 minus 3. That's 2. That's 5 minus 3. That is also 2. So 1 is, in fact, our solution. All right, number 6, don't call me a monster. We're definitely going to need these in a second. So distribute, can't do that yet. Combine like terms, nope, can't do any of that. Move variables, I'm going to go ahead and move these to the left, so I'm going to add 5x. Have to do the opposite. That gives us an 8x plus 41 equals minus 7. So we move variables, add, subtract 41. That is negative 48 equals 8x. Dividing by 8. Watch those net minus signs. X should be negative 6. Again, really good idea to check this. That's negative 18. 23, 30, yep, 23. Okay, works out on both sides. All right, starting with number 7, we are going to have a few more things to do. Okay, so first, distribute. In this case, we can distribute. I'm going to go and draw the line. We can distribute because we have these parentheses over here. That's an understood 1, so that's going to be positive 3t with a negative 5 or minus 5. And I'll just bring down everything else. 9t plus 7. All right. Combine like terms, again with our vertical line. You cannot combine these two. Can't combine these two. Can't combine like terms. Check. Multiply, or not multiply, that's next. Move variables. We can move variables. We're going to do that. We're going to subtract 3t, which gives me a 6t. 6t plus 7 equals 0 pair minus 5. Add or subtract, move variables, add, subtract. We're going to subtract 7. That will give us a negative 12 with our 6t. And then last, multiply, divide. Divide by 6. So t equals negative 2. All right, number 8. Distribute, combine like terms, move variables, add, subtract, multiply, divide. Don't call me a monster. So distributing comes first. We can do that on this one. By 6 times k, 6 times 1/2. So 6 times k is just 6k. 6 times 1/2 is going to be 3, so we get 6k minus 3. Bring down 2k plus 13. And I did not draw my line. All right, combine like terms. Can't do that. Can't put these two together. One is a variable, one doesn't. One is a variable, one doesn't. Still can't do that. So no combining like terms. Move variables. We will subtract 2k from both sides. So we get 4k minus 3 equals 0 pair 13. Add, subtract, add 3. So we get 16 equals 4k. Multiply, divide, divide by 4. We get k equals 4. Okay, number 9, distribute. No distributing, we can't do anything here because we don't have any parentheses to distribute. So, combine like terms. Those two can't go together. Those two can't either. So move variables. We'll add 3x to both sides. So that gives us 5x plus 3 equals 3. Add, subtract. Subtract 3. Alright, now because we have a 0 pair over here and nothing else to bring down, we have to write a 0. There's got to be something over there. 0 pair, 5x. Alright. Multiply, divide, we'll divide by 5. And x equals 0. Because anything divided by 5, or 0 divided by anything, I should say, is going to be 0. So x equals 0. If I plug that in there, that part's 0, that's 0, so I get 3 equals 3, which is a true statement. Alright, number 10. First, distribute, combine like terms, move variables, add, subtract, multiply, divide. So first, distribute. When we distribute, we get 4x plus 1, or no, 4x plus 2. 4x plus 2. Bring down that x. Equals 5x plus 1. And I didn't draw my line yet, but I need to do that. Combine like terms. Two terms we can combine. These two right here. So that gives us 5x plus 2 equals 5x plus 1. Move variables. We need to subtract 5x from both sides. Like a good 0 pair there. That's what we want. Minus 5x. Now the problem here occurs that we have two 0 pairs. We are left with 2 equals 1. Now if you recall from yesterday, in the previous days, when we had our weird cases, our variables vanish. They cancel out. They form 0 pairs. That's it. The difference comes whether this is a true or a false statement. If it's a true statement, then it's all real numbers. Because all numbers work. They're all true. If it is a false statement, then we have no solution. Is this true or false? 2 equals 1. It's definitely false. It's false. There's no way that that works, so there is no solution. Our answer to number 10 is no solution. Alright, number 11. Drawing my line in the middle. Distribute. Nothing to distribute. Skip that. Combine like terms. Yes, we can. We can combine x and negative 6x on that side, which will give us a negative 5x. In this case, we'll just go and bring down plus 4. Now, in this case, we can actually, in this problem, we can actually combine something else. We can combine 6 minus 2. 6 and minus 2. So that would give us 4. And I'll go and bring down the minus 5x. Combine like terms, check. Move variables. Well, I'm going to use a different color. I'm going to have to move my variables, so I'm going to add 5x to both sides. And I think you can see what's about to happen. 0 pair, 0 pair, we get 4 and 4. Now again, is this a true or false statement? If it's true, it's all real numbers. If it's false, it's no solution. 4 is always equal to 4, so this is all real numbers. Okay. All right, number 12. A number decreased by 30 is the same as 14 minus 3 times the number. There's one word that tells us we're going to have an equation here, and it's is the same. Is the same, that's equals. So a number decreased by 30. We need a variable for this number we don't know. That's what variables are. They're numbers that we don't know yet. So I'm going to go ahead and use n. So a number decreased by 30. So n minus 30 is the same as equals 14 minus 3 times the number. So 14 minus 3 times that number, which that number is n, so minus 3n. Now I have to solve that. So can we distribute? No. Combine like terms? Not if I draw the line here. Move variables? Yes. I'm going to add 3n to both sides. So that's 1n plus 3n for 4n. 4n minus 30 equals 14. Add, subtract. We can do that. We're going to add 30, which gives us 44 and 4n. And we have multiply, divide. We will divide by 4. And our answer, n, equals 11. So really there are two parts of our answer that we were looking for. This equation up here, n minus 30 equals 14 minus 3, and that, along with what the value of that is. Write an equation and solve. Okay, number 13. 2 less than 2 times a number is the same as the number plus 4. So is the same as, that's equals. The number, let's say n plus 4. Okay, that part's not too bad. Now over here on the left, however, be very careful because the word's less than. The word than is going to cause this to switch around. So we're going to write 2 times a number, which in that case is 2n, minus, because it's less, 2. So this reads 2 less than 2 times a number. 2 times a number minus 2. That's what we want to look at. So there's our equation. Now to solve that, we're going to jump straight to moving variables. So I'm going to subtract 1n, which gives us 1n minus 2 equals 4. Okay, then we jump to adding, subtracting. We'll add 4. That's actually not going to work. I just did something that's really crazy. That is not going to work. That's not a zero pair. I need to add 2. Okay, add 2, so that's n equals 6. Or you could say 1n then divide by 1, but you will end up getting just n equals 6 as your answer. Okay, number 14. Janine has job offers at 2 companies. One company offers a starting salary of $28,000 with a raise of $3,000 each year. The other company offers a starting salary of $36,000 with a raise of $2,000 each year. After how many years would Janine's salary be the same with both companies? Okay, now this says when will they be the same? That means we want to know when company 1 is the same as company 2. I'm just going to write it that way. So when company 1 equals company 2. Now we want to know after how many years, so that's going to be, I'm going to say y equals years. Y equals years. So the first company, company 1, that's 28,000. This is the starting salary. That means we're going to have that just by itself with a raise plus 3,000 per year, 3,000 Y. Company 2 starts as 36,000 plus 2,000 Y. Okay, now we are going to move variables. Let me draw my line right here. So move variables. I'm going to subtract 2,000 Y. Subtract 2,000 Y from the Y term. So that gives us 1,000 Y. Now I'm just going to keep that 28,000 equals 36,000. Okay, so next we're going to have to subtract 28,000 from both sides. All right, and that gives us 1,000 Y equals 8,000. Dividing by 1,000, we get Y equals 8. So they're going to be the same in 8 years. 8 years. Now, I've run into this other problem, but this says, what would the salary be? And since it's going to be the same in both companies, it doesn't matter which one we use, but we're going to take, I'm just going to go ahead and take this first company, $28,000. In 8 years, that's going to be $3,000 a year for 8 years, which is going to be a grand total of $52,000. That's going to be the salary in 8 years. And if you really don't believe me, you can take that 8 years and plug it into this other equation right here. You'll get $16,000 and a total of $52,000. So it will be the same. That was actually the point. We want to know when they were going to be the same. All right. That's number 14. Number 15 is very similar. The long distance rates of 2 phone companies are shown in the table. How long is a call that costs the same amount no matter which company is used? And what's the cost of that call? So we again want to know when company A equals company B. So company A is going to be, wait a second, hold on. How long is a call? How would we measure how long the call is? I believe it's going to be minutes. Okay, so I'm going to have minutes, and I need a variable to represent that. Actually, if you look down here, it's 3 cents a minute, 6 cents per minute. I'm going to use M. M for minutes. So company 1 is 36 cents. Okay, 36 cents plus 3 cents per minute. And they are going to be equal at 6 cents per minute. Okay. Now, one thing to notice is that I left these as cents. That means when we get down to the cost, it's going to be in cents. Okay. Now, I have this whole time been moving my variables to the left, so I'm not going to stop now. But this is going to be a little different. This is actually a place where you might want to subtract 3m instead, just so that you don't have some problems. But this actually will work. I'm going to subtract 6m from both sides. You just have to be very careful when you do that, because that's 0. I'm going to write 0. I have to write that. So I get 36 minus 3m. Now, since I want m by itself, I'm going to have to subtract 36 from both sides, which will give me negative 3m, watch out for that negative sign, equals negative 36, and then dividing by negative 3, I'm going to get m equals 12. So m is 12 minutes. So they will be the same when you make a 12-minute phone call. Now, as far as the cost goes, let's just use company B. It's a little easier. So our cost. 6 cents per minute at 12 minutes will give us 72 cents. So you can either write 72 cents or $0.72, your choice. I'm going to go with this right here. So it's 12 minutes and 72 cents. Okay, last problem, and it's really something for us to talk about. We're going to talk about this in class. I'm going to leave this intentionally blank, okay? Make sure that you have this thing filled in, but we are going to talk about this later. And that is the end of our notes on solving equations with variables on both sides.